In this video, I wanted to go over the 3 your turn questions that are related to Lenz's law. We learned in video 252 that Lenz's law told us the direction of the current that was going to be induced in a loop when the flux through it was changing. And we talked about how to find the direction of the current using Lenz's law. So let's take a look at the first question and go through these steps. It says that there's a bar magnet pushed toward the center of the loop, which is true. There's going to be a clockwise induced current, a counterclockwise, or no current. So there's going to be an induced current if the flux through the loop is changing. The flux is changing because there's a magnet moving closer to the loop. So the first step is which way is the applied magnetic field, or the field through that loop. We know that the field points away from the north and towards the south. So right here, at the location of the loop, the field is going upward. The next step is to see, is the flux increasing or decreasing? The magnet is getting closer, so the field through the loop is getting stronger, so the flux is increasing. So then we look at our steps. If the flux is increasing, the induced field is going to be opposite the original field. And then step number 3 says, okay, find a current that will give us this induced field. So the induced field is going to be opposite the original one that was going up. The induced field is going to be going down. So find the direction of a current in this loop that will produce a downward field. Well, use right hand rule number 2. Curl your fingers in the direction of the current in this loop so that your thumb points in the direction of the field. So if I use my great artistic skills here with the knuckles here, and my thumb is going to be down like this. So you can see that you can't see my fingers because they're behind my knuckles here. But in order to have the thumb pointing down, your fingers are looping this way, where in the front here they're going to the left, and then they're looping that way behind your palm there. So the current is going this way, in the front to the left, the back to the right. So hopefully you can curl your fingers that way. That's what makes your thumb points down. So that means that if you look at it from above, the current is going this way. As viewed from above, that's going to be clockwise. Let's look at the next question. Magnetic field is confined to the region inside the dashed line. So in this question, there's only a magnetic field here. There's no magnetic field outside. The loop is pulled out of the field, which is true. So you have to realize that as you pull the loop out, the field through that loop is going to change. Right now there's some field going through it, but as the loop is pulled out, as the loop is over here, there's now no field going through it. The flux is changing, there's going to be an induced current in this loop. So the first question is, which way is the field? The field is going into the page. You can see by the crosses here. The second question is, the flux increasing or decreasing through this loop? The flux is decreasing because there's less and less field through that loop. So then the next step is to say, well, if the flux is decreasing, the induced field direction is going to be in the same direction as the original field. Lenz's law tells us that the induced field wants to oppose the original change in flux. The flux was decreasing, it wants to point the same direction so that it increases the flux. So now we have to figure out, well, which way is going to be the current direction that produces a field into the page. So what you have to do now, the field is the thumb, the fingers fold in the direction of the current. If your fingers loop this way, then your thumb will go into the page. It's hard for me to draw it, but if I'm using my right hand, and I've got my fingers like this, kind of looping like this, and feels like I'm kind of actually, let me just redraw it the other way so I'm not twisting my hand here. But if I've got my fingers looping like this, and I've got my thumb here pointing into the page, you can see this thumb, you can't see the fingernail because its fingernail is supposed to be over here, pointing into the page. My fingers are looping this way. The thumb is into the page. So fingers looping this way, which is clockwise. The thumb is into the page. Sorry about my drawing, but hopefully you remember how to use the right hand rule. So this means that the current is going to be clockwise to produce a field into the page. Let's look at one more question. In this question, it says that you have your bar magnet is sitting inside the coil that's connected to a meter. The meter is going to read the current. You're pulling that magnet out. So what's going to happen to the current? Well, the flux through this loop is going to change because now you have a field going through it. As you pull the magnet out, the field is going to decrease. So you know there's going to be a current induced. So which way? So let's think about what's happening in this loop first here. So first of all, in the loop, which way is the direction of the field? Well, you've got the north end of the magnet here. We know that the field points away from the north, right, towards the south. So the field is going to the left inside the loop because it's pointing away from the north. What's happening to the flux? The flux is decreasing because the magnet is moving further away, so the field strength is getting less. So Lenz's law says that the induced field is going to be in the same direction as the original one. So which way is the current going to be in this loop in order to produce a field to the left? So what you have to do is you have to curl your fingers in the direction of the current so that your thumb is to the left. So I can draw this one. Use your right hand, you got your knuckles over here. Get your thumb pointing to the left. Oops. There we go. And there's your thumb right here. There's your fingernail. So you can see that the thumb is pointing to the left, and that means my fingers are curling this way. Right? It's going up here, and then behind, it's going down. So if the current is curling this way, if you kind of follow the wire here, keep following here, you're going up here, up in the front, down in the back, keep curling. See, we're going up here, down in the back, we're going down here, going down here. That means we have to go left here, left here, left here, so that we can curl up here. So that means that the current is going from right to left in this meter. The question could have been asked a different way. It could have said, as viewed from the left, for example, which way is the current? So if you look at your fingers curling this way, and if your eye is over here looking at the loop from the left, then you would say that the current would be flowing counterclockwise. I hope this helps getting used to using Lenz's law. It's one of the hardest things here. So I hope that you give it a good try.